there is no condition that satisfy the planet name. So meaning it returns 0. So it returns here, or it means that it is a default uh, case if there is no uh, planet name exists. But if we write the correct name, it would return 1 because it is uh, in the first statement. As you can see, you wouldn't see a break statement, since if the statement has checked if it is satisfied the condition, it would exit or and evaluate the the evaluate statement. And lastly, evaluate the plan if evaluate true, meaning when we evaluate this one, it is already true. So the only thing that we can print the 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 planet number is to check if the planet name is equals to Mercury. But if if the condition does not satisfy it, then we move 0 to planet number. But since Mercury existed, since our after moving Mercury to planet name, we haven't moved any or update the planet name, then we will get 1 since our planet name would remain Mercury. So just like that, so switch planet number. So case 1, planet name is equals to Mercury. Then the default would be when other. Then move the planet name to uh, non-space. So our example here is uh, if we evaluate quantity, also as you can see, we evaluate the quantity, also it is set to true, and also if it is a member. So meaning when we convert it to a switch statement, we can say that switch quantity, then true and member. So we will check the quantity. Our quantity has set to 8. So it would check. So as you can see, 1 through 5. So it loops from range 1 to 5. So since our value is 8, so we need to move to another when statement. So 6 to 16. Is it true? Yes, it is true. So we check for the next state for the next one, which is true. We also need to check the VOP if it is greater than 501. Our VOP is 800, meaning 800 is lesser than 501, which is false. So we move to another statement that satisfied to the quantity, which is here. So the quantity is 6 to 16. So we also need to check if it is lesser than 2001. So it is true. Then we also need to check the member. So our member value is y, meaning when we check this one, it is true. Then we move 12 to discount. So the discount would be displayed 12.00 since the format is we have a decimal value. So meaning that is the final result. So perform paragraph name through paragraph name. So perform 100 dash triple x through 100 dash triple x dash exit. Meaning here is that if you want to perform like you can specify a function that will exit directly. You can use this method of perform. See, like if example I have 100 dash triple A, then display in 100 triple A, then it would directly exited it since I also called the 100 dash triple x dash exit. So meaning instead of rewriting again the exit in every uh, function or the perform this one, instead of writing each exit on it, why not use a function that would directly exit it? So that is an implicit exit in every paragraph. So why do I need to code it explicitly? So it would have a lesser code, so you won't repeat yourself. So perform x times, move 5 to count, then perform count times display triple x. So and perform. So perform 100 dash display count times, meaning if we display this, it would display 5 times. So perform until, meaning just like example, move 0 to x. So our value of x is 0. So until x is greater than 10, it would perform this block of code. Then if so, add 1 to x, move x to x edited, then we display the x edited. So meaning when we move x to x edited, for example 0, when move to x edited, we display 0. 0, 1, 2, then 9, then since until 9 only, since if we translate it to another programming language, until x is greater than, it means that x until x exceeded the value of 10. So meaning it would perform until x is greater than 10. So is 10 till 11. So 10 would be printed out, and when 11 is greater than 10, so it would exit the loop. So you can also use until x is greater than 10, or maybe with test after until x is greater than 10. So meaning after the value of x exceeded to 10, then we will perform the test. Keyword. So inline perform. So perform varying x from 1 by 1 until x is greater than 100. So 101, when the x is value 101, then it would exit this loop. So the printed values would becomes 1, 2, 3 until 100. So here, varying x from 5 by -1 until x is equals to 0. It is a descending order, which we will start from 5 until x is equals to 0. Meaning, uh, we uh, we set just like a while loop, while x is not equals to 0, then we also minus it by 1, or maybe a for loop that is a descending style of looping the values, which give us the result of 5, 4, 3, 2, 1, 0. So move 10 to x. So we perform with text with test after until x is equals to 0. As you can see, display x, our x is 10, subtract 1 from x. So it means 10, 9, 8, 2, 0. So the alternate perform. So here, we have perform 100 para, uh, varying, meaning the perform 100 para, it is this it is direct directly called display the value of I and j during looping from varying I from 1 by 1, so meaning increment by 1 until I is greater than 5. After after j from 1 by 1 until j is greater than 3. It is like a for loop here, like I but from 1 by 1 until I is greater than 5, which is int I is equals to 0 and I is, or maybe 1 since it started with 1 here, and I is lesser than 5, then I plus plus. After means we need to finish performing this before performing the outer block. So int j is equals to 0, then j is lesser than 3. So until j is greater than 3. So if 4 is lesser than 3, which is false, it would exit the loop. Then j plus plus increment by 1. And then we print the I and j, which is here. We included it in this perform task, which means it we explicitly use the perform by joining the function of 100 para in displaying I and j, and the varying I and the loop. I mean, so when evaluate, so as you can see, it is the position of the keyboard or the screen, I mean. So when L arrow also to 10, so we will subtract it from the position. So this whole program is executed by this following conditions. We move, we subtract, if when del k also any, or also any, means that if del key, if it is the value of del key, then any, then we perform delete char. So our example here, so we set the values to no values yet. We create a negative and a positive number to check, which is negative 1, 2, 3, 4. The value of class 1, which is A, B, C, D for testing classes. We create also a Cobol conditional, which means that 88, which was the level number 88 is a level conditional, which means you can also um, uh, declare a condition where, like, if pass, its values are 041 to 100. So meaning if the values are or if the value is 42, then it is a pass. But if it is lesser than 40, it is a fail. So we set 25 to num1 and num3. So we just like a regular declaration, we can use a uh, b comma by using comma is equals to 25. Then we set 15 to num2 and num4. So you may notice that I may said that move is only to alphanumeric, but it can also be used to a number, since alphanumeric is a combination of alphabet and numeric. So relation condition. So it compares two operands, either of which can be identifier, a literal, or arithmetic expressions. Algebraic comparison of numeric fields is done regardless of size and usage clause. For non-numeric operands, if two non-numeric operands of equal size are compared, then the characters are compared from left with the corresponding position till the end is reached. The operand containing greater number of character is declared greater. If two non-numeric operands of an equal size are compared, then the shorter data item is appended with the spaces and at the end till the size of the operand becomes equals, and then compared according to the rules mentioned in the previous point. Since we're not discussing the string, since we will be out of time, then we'll just focus on the numeric operands. So the syntax of it uh, is data name or arithmetic operation. You can use is, or you can use not, then equal to, instead of using the equal signs, greater than, less than, greater than or equal, or less than or equal, then the data name or arithmetic operation. So a condition name and evaluate verb condition. So a condition name is a user-defined name. If the contains a set of values specified by the user, it behaves like Boolean variables. They are defined with a level 8 number 88. It will not have a pick clause. So example is 88, the condition name, the value is or are, the literal, true, literal. So evaluate verb is a replacement of series of if-else statement. It can be used to evaluate more than one condition. It is similar to switch statement in C program, just like our example earlier. So here, as you can see, we have a relation condition. So if num1 is greater than num2, then we display num1 in loop 1 if block num2. So 25 is greater than 15. So if num3 is equals to num4, which is false since 15 is not equals to 25, we display num4 in loop 2 else block. So as you can see here, I didn't use the and if, because if you use and if is used when it is already uh, uh, it is the if it is an if else statement, not just an if statement, or maybe an nested else if else statement, nested if statements. So our condition name is here. So we display if pass, meaning this variable, it is being declared or initialized to the value pass. It is like if before we enter the if statement, we sometimes we use a variable to store our conditions, so that if we want to use it again, we can use the pass variable instead of having a long condition name, condition statement that would uh, that would give you more time to write code. Also, if you want to change from change all the related ifs, the condition if related conditions by using by initializing it to a variable, you can directly change it by one only to the variable that is initialized with the condition. So since 65 is greater than 40, so we displayed it with check val marks. So pass with check val marks. And lastly, evaluate verb condition. So just like our example earlier, it is a switch statement. So when evaluate true, it enters the evaluate statement. And the only thing that it would check is when num1, like uh like while true, or maybe a while true, then it check is num1 lesser than 2, which is false since 25 is greater than 2, 25 lesser than 19, which is false, and 25 lesser than 1000. So we display num1 is less than 1000. So the negated and combined condition. So negated condition is given by using the not keyword. If a condition is true and we have given not in the front of it, then its final value will be false. So if we use it to another language, the not uh, keyword, it is an exclamation mark to another programming language. So if not, then condition, then Cobol statements, then end if. Or a condition contains two or more conditions connected using logical operators, and or if condition and condition Cobol statements. So just like the other programming language, the combined condition. So if not num2 is less than num1, then we display num2 is not less than num1. Meaning that if num2, uh, when we uh, when we executed this condition, if not 2, so meaning if there is no not here, so num2 is lesser than num1, it would return a false. But since it has a not, so it would negate it to true, which means that we can display num2 is not less than num1, meaning 60 is greater than num2, or num2 is not lesser than num1. So in combined condition, if num1 is less than num2 and num1 is less than 100, then we will display combined condition. So num1 is 60, which 50, which is lesser than num2, which is true. But if it will throw a false statement here, it would directly goes to else statement. Then we'll read the second condition, which is num1 is lesser than 100. So 650 is lesser than 100, so we will display a combined condition. So in our sign condition, we are checking for a negative or positive value. So we will use, is it positive? So is neg num is positive or neg num is negative? So meaning, even if the the value here um, is like example neg num, which is a negative value, then but since neg num but since neg num is a negative from the second condition, it would return true, since 0 or 1 would always return 1. So we will display neg num number is positive. So checking for negative or positive values. So if neg num is negative, then display neg num, a number is negative. So for the class condition, checking if a variable is certain data type by using by using an alphabetic or a numeric. If we use alphabetic, it would check if it is an A to Z. If it is numeric, 0 to 9. So if plus 1, which is A, B, C, D, so it would check if it is alphabetic, so true. So it would return it directly, since we are using or. So if the first statement uh, return true, then we need to display it. We will uh, uh, implement the values that is under the if statement. So in here, if class 1 is alphabetic and not class 1 is numeric, which class 1 is numeric is false, but since we have a not statement, then it would return true. So if class 1 is alphabetic true and true, then it would return true. So class 1 is alphabetic and not numeric. So for our activity, so calculator or so make a calculator program using Cobol. So the program that accepts to input an operator. So just use the four common verbs to multiply, add, divide, and add. So you should apply the conditional accordingly. So you can use the online compiler to run the program. Send the PDF file after clicking the pretty print. So you can get the following format to my GitHub account, which I will give the link later on. So our example for the calculator is like this. This is my own format, but you can use a nicer format if you can give it a nicer look. So if we enter for first number, then enter the operator, then enter the second number, it should print cannot be divided to 0. So it is using a conditional statement. So 0 cannot be divided to 0, since 4 divided by 0 is not is an error. So here you can uh, when we enter 5, then divide by 7, you can display this one. So this would be the output that I want to see on the activity. So in our online compiler, so as you can see, if you want to use an online compiler, then you can use this one instead, since it is accessible to everyone. No need to install it. So maybe you can just print you can just screenshot this whole um, page, or you can save it as a PDF by clicking here, then clicking pretty print. So as you can see, in your programming languages later on, when you're going to give a task, you can use this for compiler for online compiler. So our sample formats would be like here if you want a PDF format. So for questions and clarifications, so I will just paste this link below the description below. So if you want the IDE, you can just download this one instead of going for an online compiler, since in IDE you will be guided by the format of the when writing the code. So for format, the uh, three common verbs. So you can get it here in my GitHub repository. So this is the references I am using. So that's all, and thank you.